Part 2 of 13.6. In a survey of pet owners, 45% own a dog, 27% own a cat, and 12% own both a cat and a dog. What is the conditional probability that a dog owner also owns a cat? So here's what we're looking at. If they're a dog owner, what is the probability that they own a cat? So out of all the dog owners, how many own a cat? So here's what we're looking at for our formula. The probability that they own a dog and a cat, which would be the 12%, divided by all the dog owners, 45%. So this answer is 26%. The second question says, what is the conditional probability that a cat owner owns a dog? So here's what we will be looking at. What is the probability that they own a dog given that they already own a cat? So again, we want cats and dogs, which is 12%, divided by all of the cat owners. So the cat owners are 27%. This works out to be about 44%. The same survey showed that 5% of the pet owners own a dog, cat, and at least one other type of pet. What is the conditional probability that a pet owner owns a cat and some other type of pet given that they own a dog? Here's what we'd be looking at. What is the probability that they own a cat and some other type of pet given that they own a dog? So out of all the dog owners, then we go to the previous slide, the dog owners is 45%. What percent own a cat and other? So that would be the 5%. If I work that out, I get 11%. Part B, what is the conditional probability that a pet owner owns a dog and some other type of pet, given that they own a cat? Here's what this would look like. A probability that you own a dog and some other type of pet, given that you're a cat owner. So the cat owners are 27%, and other is the 5%. So we're looking at 19%. Remember, you can leave your answers as fractions, decimals, or percents, as long as they are reduced. Let's look at a tree diagram. What is the probability that a student who helped set up walked in an event? So here's the data. We have students that helped set up for an event or did not help set up for an event. Then we have either they walked in the event or they did not walk in the event. Notice if I add vertically, I get 100%, up top 100, down below 100%. So we're asking, what is the probability that a student who helped walk in the event also helped set up? So out of all of those who set up, what is the probability that they walked? That means our student would follow this path where they helped set up and they walked. So what we're going to do is we're going to take 85% times 80%, which gives us 68%. Number 2, what is the probability that a student who did not help set up walked in the event? This is going to be someone on the yellow path. So they didn't help set up, and they walked. So this gives us 9%. Number 3, what is the combined probability of students who walked in the event? So then we have to go through and figure out these outcomes. So what's the probability of setting up and walking? Setting up, not walking. Not setting up, walking, did not set up, did not walk. So this first answer is going to be 0.85 times 0.8. 0.85 times 0.2. And this is what it would look like if I finished up the column. So we are looking for the combined probability of students who walked in the event. So walking happened here and here. So we need the answer to this and the answer to this. Here are the percentages for those results. So if I add those two together, I get 77%. Here's another tree diagram. It says, let's make a tree diagram from the following data. So I've already started mine. 70% of freshmen attended public school. 60% of freshmen were at public schools and they graduated within 5 years. 80% of other freshmen graduated within 5 years. So our categories are public or private, and then did they graduate within 5 years or not? So these are my categories. The first thing I decided to look at was public or not public. Then once they made that decision, either they graduated within 5 years or they did not. So then what I want to do is add my percentages. So 70% of freshmen attended public school. So that means that 30% attended a private school. So we are talking about college freshmen picking either a public or a private school. So a public school would be government funded, whereas private would be something like Concordia. Then 60% of freshmen at public schools graduated within 5 years. So that means that this line would be 60%. The other line would be 40% because they would be complements. 80% of the other freshmen graduated within 5 years. So here's our 80%, and this would be 20%. The question is, what percentage of freshmen graduated in 5 years? So we have to take into account those that attended public and private. So public and graduate would be 70% times 60%. And then other and graduate would be 30% times 80%. So we're getting 42 hundredths and 24 hundredths. So if I add those numbers together, we're looking at 66% of all freshmen graduated in 5 years. Why don't you try drawing a tree diagram? Pause the video while you work. Here's our solution. A soccer team wins 65% of its games on muddy fields and 30% of their games on dry fields. So muddy and winning is 65%. Winning on dry fields is 30%. The probability of a field being muddy for the next game is 70%. So those are the numbers that were given to us. Now we have to find the complement. The complement of 70 is 30. The complement of 65 is 35. The complement of 30 is 70. The question is asking, what is the probability that a team will win their next game? So we win on this bar, and we win on this bar. So that's 70% times 65%, 30% times 30%. So we're getting 0.45 and 0.09. And if we add those together, we're looking at 54%. If the probability of the field being muddy increases, how will that influence the probability of the soccer team winning their next game? Looking at the data from the previous slide, the probability of us winning in the mud seems to be higher than winning in the dry field. So the question is asking us, if the probability of the field being muddy increases, how would that influence the probability of the soccer team winning their next game? I would say we played better in the mud. So the higher the probability for the mud, the more likely we are going to be to win. Here's your exit ticket. Please pause the video, try these problems, turn the video back on to check your answers. In the first question, we have a jar containing marbles. 10 large red, 4 small red, 6 large blue, 5 small blue. So what I'm going to do is I'm almost going to turn this into a table, a two-way frequency table. So my total large marbles are 16, my total small marbles are 9, my total blue marbles are 11, my total red marbles are 14. So my total of all the marbles is 25. So this is conditional probability. So when we do probability of red, given that it's a small, that means out of all of the smalls, so here's our smalls, out of all the smalls, so out of 9, what is the probability that it is red? So that would be 4. So given it's a small marble, there would be 4 out of 9 that are red. The second example, we want to assume that we are picking a red marble. So out of all the reds, so that means we have a total of 14. What is the probability we're going to get a small? So it looks like out of the reds we have 4 small, which reduces to 7. So the question is asking which conditional probability is larger? Well, if we don't know looking at the fractions, we should turn these into decimals. Here's what these approximate to. So it is asking which probability is larger. So I would say out of the smalls, the probability of getting a red would be larger. Here's the second question. A math teacher gave her class 2 tests. 25% passed both tests. 42% of the class passed the first test. What percent of those who passed the first test also passed the second test? Well, it looks like this table was from the previous example. This is what I believe the question is asking. Out of all those who passed the first test, who also passed the second test? So our denominator is going to be those that passed the first test. So 42% passed the first test, and the numerator is going to be passing the first and the second test. So that was 25%. Work that out on your calculator, and you're getting 59 hundredths, or 59%.